Hi, third grade. Miss Comer's here, and this is our math lesson for Monday, May 18th. It's lesson 21.3 on tessellations, and it's in your blue math book. It's pages 430 through 431. Hopefully you got a chance to watch the slideshow that I posted up and took a look at how by moving figures we can make them fit together in this special way. Now we're going to take a look at how using those moves that we talked about last week, we can make something tessellate. Now you might ask, what does that mean? Well, let's take a look. Twist and turn. M.C. Escher, a Dutch artist, created many works of art by combining figures in a special way. When plain figures combine to cover a surface without overlapping or leaving any space between them, those figures tessellate. The repeating pattern formed by the figures is called a tessellation. Now remember, part of the caveat here is that they cannot overlap and we don't want to leave any space between them. Let's take a look at some figures that do tessellate. If we look at this first part right here, all of those tiles, those little squares fit together, they don't overlap, and there's no space in between them. The same is true with our hexagons here. They all fit together nice and neat, they don't overlap, and there's no space in between them. And the same is true of our triangles here. However, if you look at this second row of figures, we have some circles and we have some pentagons. Now, let's take a look at those. Let's see if the definition fits here. I can look at my circles. They don't overlap, however, they do have space in between them. Therefore, I know that they can't tessellate. The same with my pentagons. If you look at those, even if I turn this and line it up, I'm still going to get some gaps in there. So therefore, they don't overlap, but there are spaces. Now, let's take a look at this piece of artwork over here. It says, describe the figure in the art by M.C. Escher. Does the figure tessellate, and how do you know? Well, once again, we're going to take that definition that we just talked about up here, and we're going to ask ourselves, okay, do they overlap? So I'm checking the figures on here. Nope, they don't overlap. Then I have to ask myself, well, are there any gaps? So I check and see there's no space, there's no gaps. So the answer is yes, it does tessellate. Now, our big idea from all this is some plain figures can be combined to form tessellations. And you see tessellations in all kinds of stuff. Our walls here at school, those are all the cinder bricks. They all tessellate, tiles on the floor. Now, number 1 here says, explain how you know that circles do not tessellate. Well, it doesn't fit the definition. We just talked about how when we look at those circles, they don't overlap, but there are gaps and spaces in between them, so we know that they do not tessellate. Now, I'm going to show you a couple different tessellations here. We have our pentagons here, okay? I started with just a regular pentagon, and I've put them together in all different shapes. But no matter how I turn those, it still forms gaps and spaces. So we know that a pentagon does not tessellate. But if we look at the next one, with our triangles, I took this original triangle, I turned it upside down, and now I can start moving these so that they fit together. Maybe. Oops, there we go. Okay. Okay, I can put that one there. I can move this one here. Scooch him up. Okay, I can take this one. It's going to fit. And as I'm placing these, notice there's no gaps or spaces. I can scoot this one a little bit closer. Okay, now this one I am going to have to turn it in order to make it fit. But I can do that. I can rotate it, and that's one of the moves that we learned, or the different ways that we can make stuff tessellate. Okay, and then I can put it into place. I can drag that down, and it fits. And we could keep those going forever and ever. Okay. So let's take a look. I want you to imagine how these will or will not tessellate. On this section of your work, we're supposed to tell if it will tessellate or not. We're just simply supposed to write yes or no. So let's take a look at this. That first figure that we have is an oval. Okay. Well, I already see that I have some curved edges. It's similar to a circle. If I started stacking those and manipulating those and moving those, would they fit together? I could make it so it wouldn't overlap, but if I had one right next to it, I'd still have spaces. So our answer on number 2 is no. How about number 3? Well, it's a rectangle. And if I started stacking those and laying those out, I could put one here, I could put one on top, put one on the end. I could keep going. So I have to ask myself, will it overlap? Nope. Is there going to be any gaps or spaces? The answer is nope. So I know that this figure does tessellate. So we're going to write yes here. How about the diamond right there, a rhombus? If I start stacking that together, could I make that, could I start adding on to that and making it tessellate? Could I get those pieces all to fit together? Well, yes I can. I can stack it. I can make sure that it's not overlapping. And as I do that, it's like tiles on the floor. So there's no spaces. So my answer is yes, this one tessellates. Now, number 5 is the green ones that we just had on the previous page. This is a pentagon, okay? And we know that no matter how we start stacking those on there, we're still going to have those spaces. So my answer on this one is no. Okay. Number 6. Says tell if each figure will tessellate, right? Yes or no. This is exactly what we've been doing. These were like the blue triangles we had that I showed you and I moved together. They don't overlap and there's no spaces. So the answer is yes, they do tessellate. How about number 7? That's a hexagon. That was like the example that they gave us on the previous page. I can start stacking those together. And my answer would be yes, because I can put those and fit those together with no overlap and no space. Oh, and here's number 8, the dreaded circle. It's got curved edges. If you take a look at the previous page, you're going to see that circles do not tessellate. So our answer is no. Now, number 9 is an interesting one. We're going to have to think about this for a minute. If I would start drawing and trying to copy that shape, I could keep it going. I could probably get all the way around. But what's going to happen when I get into this area right here? Remember, the definition is they can't overlap and there can't be any gaps or spaces. No matter which way I turn this figure, it's not going to fit into this space right there. So without having gaps. So I know that this one will not tessellate. So we're going to put a no. Number 10 says trace and cut out each figure. I'm going to go ahead and let you do that at home. Trace it. Work on putting those together. See if you can make several of those. See if they'll fit together. And you may color your design. I want you to play with these figures and see if they fit together. Now, you can have mom or dad or somebody check and see if your figures are right. And I want you to think about those two things. Do they overlap? And are there any gaps or spaces as you fit those together? So that's how I want you to do numbers 10, 11, and 12. Number 13 says, is this a tessellation? Explain why or why not. This goes right back to the green pentagons that we looked at just a few minutes ago. And as you can see, they've rotated them, they fit them in upside down. But what do you notice right here and right here? Okay, if we go back to our definition of what a tessellation is, it can't overlap and there can't be any spaces. But if you look where I put those two arrows, we have spaces. And you see another one developing right here. So, what is our answer to this? I want you to think to yourself for a minute. Is this a tessellation? And then why or why not? Okay? So, our answer is no. And it's because we have these spaces. It doesn't fit the definition. They're not overlapping, but they do have spaces. Therefore, it can't be a tessellation. On number 14, it says, write about it. Explain how you know that this figure will not tessellate. Well, what are some of the things that you notice about this particular figure? First of all, we have some rounded edges. We know that when we start adding those together, what's going to happen here? Okay, it's going to be the same as what we noticed over there. We're going to end up with those spaces, and with our definition of tessellations, they're not overlapping each other, but I'm getting these spaces in these sections, so therefore it can't tessellate. Number 15. Pilar wants to buy 6 pencils. Store A sells 6 pencils for 49 cents. Store B's price is 9 cents each. Where should Pilar buy her pencils in order to spend the least amount of money? Well, here's a story problem. So let's take a look at this and see what we need to do here. Okay, so the first thing I'm going to take a look at, and I'm going to change colors here, is what am I supposed to find? Here's my question right here. Where should Pilar buy her pencils in order to spend the least amount of money? Okay, we always have to know what we need first on that. Okay, the second step is we've got to go back in there and figure out where I find this information. I know that I have 6 pencils, okay, that Pilar is trying to buy. And Store A sells 6 pencils for 49 cents. But Store B's price is 9 cents each. I have to think to myself, what operation do I need to use in order to figure this problem out? I have 6 pencils at 9 cents each. Okay? I see that word each. Remember, that's my clue word when I'm multiplying. Okay? So I'm going to do 6 times 9. Okay? Now, hopefully I can remember what that is. It comes out to 54. Now, because this is money, we have to show it as money. Okay, so Store A, the 6 pencils are 49 cents. Store B is 54. I have to think to myself, which is the better price? Is it 49 cents or 54? Well, if we take a look at that, 49 cents is less than 54 cents, so Store A has the better buy. Now, I would like for you to take the time to do numbers 16 through 19, just to refresh your memory and so that you can remember how we do some of these. It's always good to take a look at these. You're going to go ahead and do your addition here and here. And then this is just a little refresher on what a number is in standard form. Now, standard form just means a regular number. Okay, so you will select from your choices right there.